Hello to you all. My name is Rami Ziv from Norris Medical. Today we're going to be going over the engineering side to the extramaxillary zygomatic implant placement technique. I will be shutting my video right now so that it will be easier for me to concentrate on the webinar. And let's start, and I hope we have a great webinar. So the goal of our lecture today is actually taking us from the medical knowledge of what to do to understanding how to do it. But before we start, I would like to thank Dr. Yigal Balan that has been working with me for many years and actually brought me to this magic world of zygomatic implants. And our subjects for today are the typical maxilla structures, semi-atrophic maxilla, severe atrophic maxilla, knife edge, zygomatic implant trajectories, hybrid, one posterior implant per side, hybrid taking into account an anterior zygomatic implant insertion in the future, quad zygoma, 2 zygoma implants per side, where there could be in several trajectories, non-crossing or crossing. We'll go over the Zygo classifications from Dr. Carlos Aparicio, and I'll be presenting Zygo classifications in reality. Traditional Brennemer concept for intrasinus procedure, Norris Medical extramaxillary procedure versus traditional intrasinus technique, Norris Medical implants and accessories, the geometrical rules for zygomatic implantation, the what I call the orbiter angle, sinus angle, and the parallel view for collision prevention. We'll go over the drilling procedure, implant insertion, understanding pterygoid implant geometries, and then I will be showing some 3D presentation for the procedures and 3D cases presentation of planning, and that will be all for today. So, just a minute. Okay. So the typical maxilla structures that we're facing are semi-atrophic maxilla, where we have some bone on the ridge. We have complete severe atrophic maxilla. We have no bone on the ridge at all. Very, very thin ridge. And knife edge, where we have ridges which are very, very thin. They look high, but there is no possibility to, or there is sometimes possibilities to put implants. But then we have to think whether that would be the best thing to do, or maybe to use a zygoma implant. So let's look at some implant trajectories. We have the hybrid trajectory, where we have teeth and we just need to add an anterior and posterior implant because we have no bone. We have another hybrid session where we can put anterior implants, but we don't know what would be the bone situation within, let's say, several years from now. So if we plan the anterior positioning of the implants and we take a posterior zygomatic implant, if we plan correctly, we can leave enough volume of bone to enable insertion of future zygomatic implants. So I call this hybrid, taking into account zygomatic implant insertion in the future. We also have quad crossing implants, which are crossing. We have the posterior implant going above the anterior implant, and we have non-crossing. And as I said, we also have a knife edge. So let's start by understanding a bit what are the Zaga classifications. The Zaga classifications were described by Dr. Carlos Aparicio, and the description is as following. Type 0 is when the zygoma implant basically passes from the palate through the sinus towards the zygoma bone. Type 1 is called sinus slot, where the implant is actually on the ridge, perforating the maxillary sinus wall, okay, exposing the membrane and anchored in the zygoma bone. Type 2, we have the implant further out, where the implant is not perforating the maxillary sinus wall, is leaning on the ridge, and anchored in the zygomatic bone. We have type 3, where the implant is completely away from the maxillary sinus wall, leaning only on the crest and in the bone, in the zygomatic bone. And we have type 4, where we have no support from the alveolar ridge at all. The implant is only anchored in the zygomatic bone, and we do or do not have this kind of curve. It could also be the same situation where actually the implant is leaning on the maxillary sinus wall, but there is no support at all, and the implant is only anchored in the zygomatic bone. If we look at some cases from my computer, okay, so this is how it would look at Zaga 1. Well, this one is basically something like between Zaga 1 and Zaga 4, because the implant is actually only anchored in the zygomatic bone. It is, however, perforating the maxillary sinus wall. That's why I would say it's Zaga 1, but we have no support on the ridge. Okay, so it's kind of a combination between Zaga 1 and Zaga 4. If you look at Zaga 2, that would be mostly happening on the posterior implants, and it looks like that. We have the implant anchored in the zygoma bone. We have the implant leaning on the crest and not perforating to the sinus. Zaga 3, we have the implant leaning on the ridge, not positioned far from the maxillary sinus wall, and anchored in the zygoma. We can see it basically in our eye. In this situation, it is very important to check if the movement of the implant forward will not affect the face, because sometimes it might change the way the face looks, and the patient will feel the implant very much because it's moved further to the front. So this has to be taken into consideration. And Zaga 4, we have the implant anchored in the zygoma, does or does not perforate the sinus, depending on the sinus, the way the sinus is there. And basically nothing is supporting this implant at all. Okay, so this is Zaga 4. This will be on severe atrophic maxilla, usually on the posterior implant. So let's look at the traditional concept of intrasinus procedure. The implant was entered through the palate towards the zygoma bone, passing through the sinus. Where actually, in this case, the surgery requested opening a window because nothing was, basically the surgeon is blind. He cannot see what he's doing because he doesn't see anything. So window was supposed to be open for the surgeon to peek inside and try to find out where to enter the implant. It's not easy. And because the implant is positioned on the palate, the position on the palate is like that, which is very complicated for the restoration. Okay, the restoration would look like that. So not very friendly. The extramaxillary technique actually moved the implant outside of the maxilla. By that, it enables the surgeon to see what he's doing. Basically, the implant is, everything is open up to this point. So everything can be seen and controlled. And this is very important for this procedure. So, and as well as this is a bypass to the maxillary sinus, the implant is anchored in the zygomatic bone, and leaning or not depends on the alveolar crest, on the alveolar crest. The torque resulting is very high, and it's requiring, these angles are requiring different or additional multi-unit angles. So actually what we have is 45, 52, and 60 degrees in order to be able to correct the angles because of this procedure. This is just a typical picture of how the extramaxillary looks on a model. Well, if we talked about the restoration, so this is how the restoration looks like when we have an intrasinus procedure, where we have the implant going in through the palate, versus the extramaxillary, where we can position the implant on the crest wherever we want it to be, and to receive a very nice restoration curve. So, what is needed for the extramaxillary technique? So the success of zygomatic implants placement relies on surgical and mechanical skills, of course, on knowledge of the anatomy, understanding the procedure angles, good 3D visualization ability, we'll see that later on, and of course, good planning. The implant itself is quite different than what the previous implant looked like. It has a machined collar, one-dimensional, no dimension is 4.2 millimeters all the way long, and the implant and what's actually entering the bone and being anchored in the bone is a sharp, deep thread geometry, which is bone condensing and self-tapping implant, very much like the tough implant. The length here is 16 millimeters. Okay, the implant itself has a 2.42 hexagon, like a Zimmer platform, and smooth machine collar and RBM surface treatment in the implant itself. The implant's lengths come from 30 millimeters up to 60 millimeters, and that's because this is the variation that there is. 30 millimeters would be used usually on posterior implants, versus 60 millimeters will be used on anterior implants, where we want to have the multi-units going out, let's say at the second position or on the canine. The surgical set includes drills which has lengths from 80 millimeter long down to 40 millimeter long to enable working on the very crowded space of the mouth. The implants themselves, as I said, these are the lengths, 40, 50, 60, and 80. The implants they have different shapes, and they are they are form drills where we have the diameters changing. I'll see it on the next slide. The number one implant will have this geometry. Number two implant will have this geometry, and number three will have this geometry. And we have to make sure that we choose the right implant from the set. We don't want to use the wrong drill. Sorry, we don't want to use the wrong drill from the set. Okay. Most of the drills we're using would be, like in 90% of the cases, we'll use drill number one at all, just drill number one. We will go up to drill number two if we try to place an implant and we get a too high torque. So we just take the implant out and we take drill number two and we drill, because we don't want to waste any bone and drill with a bigger diameter drill and lose bone that way. So from my experience, like 90% of the cases are done with drill number one. So as I said, the geometry of the drills are like this. So drill number one, we start from diameter 2 up to 2.5 and 3 and then 4.2. All our tools are basically, all the chunks of the tools are 4.2 because the implant is 4.2. So we have in one drilling process, we can have this geometry, which is, as I said, good for 90% of the cases. If we do have some resistance and the implant the torque is very high, and we want to increase the drill hole, we'll use drill number two, where actually what we're doing, we're increasing the hole to a 2.8 and then to a 3 millimeters and then 4.2, okay? And then we put the implant further again. We also have diamond burrs, which are the tool to actually curve the way on the maxillary sinus wall for the drill to go in correctly without curving this groove. In cases where the drill has to perforate the maxillary sinus wall, it will not be able to do so because a drill doesn't work on the side. This is why this important tool is needed. We'll see it later on. So let's look at the procedure. And entering positioning was defined. The diamond tool is actually making the groove on the maxillary sinus wall. After that, a drill is being drilled. The depth of the implant is being measured. An implant is being positioned. Basically, if you see, the groove becomes a bone guide for the drill. We'll soon see how to define this angle, because this angle is very important, and we'll see how to define it. Another thing which is important is to put the implant in the correct orientation. First of all, we need to put the implant on the crest in the right position, and then on the right orientation, so that we will have the multi-unit position perpendicular to the ridge the way we need. Okay, so let's look at the maxilla. On the maxilla, when you raise the flap, you have to make sure that we're very careful not to interfere with the infraorbital foramen. The zygoma itself does not pass that way, but when we raise the flap, we have to make sure that we see it and we don't damage the infraorbital foramen. So when we place a single zygomatic implant, usually its position would be the first premolar, second premolar, depending on how further back we want to have it, maybe even on the first molar, depending on what we have. This would be the position on the crest, and the implant itself is going to be directed towards the zygoma notch, okay, further from the orbit. This is the orbit, further from the orbit. If we want to place double zygoma we can place in two ways. In this case, I call it non-crossing. Okay, we see the implants are not crossing. Usually the position on the crest would be canine, around the canine position, canine or second lateral or the lateral, okay? And the distance from the orbit, from this angle that we see would be between 5 to 7 millimeters. We'll talk about this distance later on. The posterior implant will start the second premolar or first molar, depending on the case. And it would be positioned in such a way, that usually that would be we have to look at the temporal fossa here. That would be the usual way where we would put it. And we have to make sure that we are not colliding with the anterior implant. In this case, where the implants are not crossing, we should not be afraid of that, because we are not going to be colliding, because basically we're quite parallel. Okay, but if we are in this case, for instance, the anterior would be the same, starting from canine towards the closest possible distance to the orbit without perforating the orbital rim. And the posterior implant, now we have to make sure that the posterior implant will not collide with the anterior implant. We'll further on see how it's done. Okay, so this is how the implants are done. I'm showing implant number 23 because I'm going to be talking about this position later on in the lecture. Okay? So the geometrical rules for the zygomatic implantation. Big question. So what we want to do is actually, the goal is placing the zygomatic implants in the correct angles. Now, which are the correct angles? This is the question. From outside, it would be looking for one implant, or a double implant would be looking like that. So here are the geometrical rules. First of all, you have to define the implant direction using the orbital angle. I will describe the orbital angle in a minute. Then we have to find the entry point to the zygoma bone based on the sinus angle. And then for double zygoma implants, collision prevention between crossing implants using the parallel view. We'll be talking about these three rules during this lecture: the orbital angle, the sinus angle, and the parallel view. What we see here is we see the maxilla. We see one implant position. So this implant, this is the direction of the implant. This is the boundaries where we are allowed to be with this implant. Okay, superiorly it would be a distance from the orbit, where we have to be careful from the orbita. And we have another boundary which is falling into the temporal fossa. Okay, this angle, I call it the orbital angle. Okay, when I say orbital angle, it's the angle from, if we go superior, we hit the orbital. If we go inferior, we hit the infraorbital. This is the orbit angle. But there's another angle involved. It's the sinus angle. It's actually how much this implant is falling here, going deep inside or outside. Okay, we see it on this view. This is a 90-degree view of what we see here. Okay, so this is the position we want the implant to be positioned. Okay, anteriorly and posteriorly. These are the boundaries that we have. If we go too much anteriorly, we actually are going to crack the bone and the implant is not going to be positioned correctly. If we go posteriorly, we fall into the sinus. This is why I call it the sinus angle. That's when I say sinus angle, it's between falling to the sinus or going outside of the bone. This is the sinus angle. The entering point is somewhere here where this bone here, this bone here actually meets the central point of the implant. This is the entering point. And there's another, and another point which is actually giving us this direction is the amount where actually the implant is going to be positioned on the crest itself. So if we take the diamond and we start from the entering point and we go down and we move the bone here, it defines for us a vector going this way. And we will need to find a way how to do this vector. Whenever, you know, we heard a lot of cases where implant hit the orbita. One of the most interesting things is the only angle that the surgeon can see is this angle, because this can be seen outside of the face if it's checked correctly. So every time we see an implant in the orbit, that means this orbital angle was not checked or not understood or whatever you want to call it. But this is the only easy angle to see. This angle, we can analyze it. We have tools for that, and we'll see how we find it. But it's much more difficult to find this angle than finding this angle. If we're talking about double zygomatic implants, okay, so we have the anterior implant. We will position the anterior implant as close as possible to the orbital rim. Why as close as possible? Because we want to leave enough bone position for the posterior implant to go further in. Okay. As I said, this position, the apex of the implant, we want it to be as low as possible, meaning that the sinus angle would take us so that the implant, let me go back to this, we'll take the implant going this way, okay, towards the sinus. Okay, this is what we want to do in this case. Okay. And now the posterior implant, it also had a boundary. The boundary is not falling into the temporal fossa, even though in some cases it is not a rule not going in here. But when we do, basically we are injuring the masseter muscle, which is here. But in some cases, the only way to position a posterior implant would be to go from the infratemporal fossa, entering here, towards the bone, because this would be the place where the bone of the zygoma is. So it is also possible to do that, but I'm talking about now like the mainstream, not really extreme cases. But I've seen many cases where the implant is actually going through temporal fossa towards the zygoma itself. Okay, so the implant itself, in this case, we have a collision alert because we are crossing, and we want to make sure that we don't hit the anterior implant. So the reason I said that the anterior implant has to be low is because that in any case, the posterior implant will always be above the anterior implant. Okay, it will always be above, and in this case, it must be above much, not to collide with the implant itself. Okay, when I said that this is the angle that we can see, actually we can see this from outside of the face, but actually what we see, this is the distance that we see. Okay, because when we look from here, this is the distance that we see, but actually this is not the real distance from the orbital rim. This is the distance from the orbital rim. What we see here is this, but actually the distance from the implant position to the orbital rim is between the two yellow lines, which is actually much smaller than what we actually see. So even if we think when we look from here that we are outside of the orbit, it doesn't mean that we are outside of the orbit. We could be inside of the orbit because of this phenomenon. So this has to be closely checked prior to the surgery, defining what would be this distance. So how to find the orbital angle? Big question. Okay, what we see here, we see the ridge. Okay, this is the nose, orbita, central. This is the center. Okay, and somewhere here is our line. How do we find that? So this is something that what I'm presenting here is probably one of many ways to do, but I know this way works, and I've been showing and seeing that for many cases. So it is a recommendation. Whatever you can find or do in order to find the orbital rim is fair enough. I'm just giving you one way of doing that. And we start by actually, I would say something more before I continue, because sometimes the flap is raised so much that we can see the orbital rim under the flap. But not always we want to raise the flap so much. And what I'm showing you here is a way that we can avoid raising the flap too much. Okay, so we decide the point that we want to have the implant positioned on the ridge. This is where we want the multi-unit of the implant, of the anterior implant to be, or any implant to be, okay? If we want to make a double zygoma, we'll probably go this way, but let's say we want to have one implant. Okay, so we decide the position on the crest where we want the position to be. So we decide this would be the point. We take the diamond burr, we aim it somewhere to this direction, and we make a small mark on the crest. We're not damaging because we're going to be using this groove anyway later on. So we just make a small mark. Okay. Now we take a pointing drill, and we try to analyze where would be a reasonable position for the line to go towards the orbit. We see the orbit is here, right? Okay. So we make a small hole here. If this hole is just going to help us to find actually the line. Now, between these two geometries, there is a line passing between these two. So how do we see this line? What we do, we take the drill from the set. We insert the drill from the set to the hole we have placed, and we lean it on the groove on the ridge. Now we can close the cheek, and actually what we can see the implant here. You see the implant? The picture is not so well. We see the implant here. We take a ruler, and we put our eye in a view like this, that we see the ruler exactly on top of the drill. And we see where the ruler is going, and we marked where the orbital rim is. And then we can see this distance, okay? This is what we want to see. If we see that, we know we are okay. But what happens if we see that? That means that basically our line is going to take us directly to the orbit. That's why I said that this is something that has to be done. And if we find an implant in the orbit, then it's probably was not done correctly. If we do find ourselves in this situation, or let's say going further back below the temporal toward the temporal fossa, then we go back. And basically we want to move this hole to a different position. So we make another mark. Now these marks are not the entering point. They're just marks in order for us to define the line, okay? The sinus, the orbital angle, okay? So we might make another mark. We do the same. We put the drill, we close the cheek, and if we come up to this position, we know we are okay. Okay, so we are very good. And this is the line. We take a pencil and we actually mark the maxilla with a pencil. If we do it with anything else, it will just wipe off. If we take a pencil, it will stay. Okay, so we take a pencil and we just draw with a pencil. Now, somewhere along this line is the entering point. Remember the entering point that's telling us the sinus angle where we are. If we start from here or here, we'll be differently positioned towards the sinus or the zygoma bone. So how do we find How do we find this point? This is the question. Okay, so remember implant 23? This is implant 23. This is the orbit. This is the central point of the implant, central line of the implant. And this is the entering point. This is the point that we're looking for. If we find the insertion point, and if we know this line here, okay, and we take the diamond and actually remove this amount of bone, we're actually aiming towards the correct direction of the implant. Okay, we're having correct direction with two angles, because this line, actually this line here, is the orbital angle line that we marked with a pencil, and this entering point is on the sinus angle. So actually, I will be rotating this picture because I'm going to a model that will help us understand. Okay, this is a model. It's not actually correct in terms of the bone, but this is the model of showing us as a goma. We see the sinus, we see a alveolar ridge, and we see the multi-units. Okay, so this is a central line of the implant. Okay, as I said, this is where the entering point would be, the point where the center line crosses the bone. Okay, the entering point would be here. This is the insertion point that we're looking for. Okay. Now this insertion point has a distance from the top of the zygoma bone. Actually, when we're looking from here, it's like we're facing a mountain. We cannot see the other side of the mountain, but we want to have a tunnel in this mountain, and we want to make sure that we have the tunnel correctly. So if we can measure, if we can take this implant and put a parallel line to this implant, it has to be parallel line to this implant. We measure this point, we will know where this entering point would be. Okay, we'll see it very soon. Once we find this point, we mark it with a drill, and then we start working. But let's see how we do that. Okay, what we see here, we see this is the maxilla, where we have the diamond actually positioned, and this is the angle of the orbital angle. This is the pencil mark that we put on the ridge. Okay, this is how it looks from the side. Okay, this is a isometric view. What we see here, we see the diamond. We let's say we took the point that I showed in the previous slide. We put a point here. It's a checking point. Okay, it's not the final point. It's a checking point. We put the diamond on this point. Okay, and we move it down this way. We move it down this way until it meets, until it comes to the bone here, and actually remove this bone. Okay, basically what we've done now, we have this angle and we have this line here that will show us how much we went down. Okay, because if you can see, the continuing of this line is actually the line that we want to be. This is the line that we want to be, but we have to know if we are on the right position. Okay, this is how it looks in 3D. Okay, we see the diamond going down, and now we're going to be, okay, I forgot to continue with the slides. Okay, so we have, this is the pencil line. Okay, this is an isometric view, the pencil line, and now we guessed this one to be the entering point, and we move down like that. We move down to this position. We started from this position, and what happened here? Let's see. Yeah, we started from this position, and we're going down to this position. Okay. This is the distance that we have if we take a tool, like let's say the depth probe, and we put it on, we lean it on the bone, on this, we lean it above this line. If we have to look above this line, it's basically, it's perpendicular to the zygoma bone. We'll see it in a different view later on. But we put it in here and we check this dimension. And if this dimension is like the dimension that we checked before, and we know, suppose we decided it has to be, I don't know, 2-3 millimeters, we check that. And if we are correct, that means we're on the right position. If not, we'll have to move this point, okay? Let's look. You see, that's what I'm showing. Let's look how it actually looks, okay? So basically we start at this position, okay? We put this position, we put the diamond, but what we see here, we see that the implant is, if we continue, we don't know that, okay? We don't know this. We know this only by the fact that we have the distance of between these two lines. If we see the distance too high, that means that we are actually going to be out of the bone, because we know this before, okay? This is how it looks, okay? If we continue, what we see when we take the diamond and start grooving up to this point, we do that while we groove. While we make the grooving, we put the groove, we go further in, we take the tool and we measure the distance. The most important thing for us is to understand, to have this distance, okay? Okay, so we talked about this one where the implant is falling too much inside. What happens if we went too much inside, if the diamond went too much inside? In this case, you see that the tool is showing us a very small space. We'll see it here, okay? If we went too much inside, this is the situation right now. That means that this distance is very small, and the implant is actually going to be outside of this bone. In this case, what we actually need to do, because we already removed this amount of material, okay, if this amount of material is removed, what we will need to do is take the tool back and put an entering point here. And then we do it again from this position, and then we'll be somewhere around this angle. Okay, so this is a tool, this is a measuring tool that gives us the way to know where we are. And once we understand that, we know, even if we've done something wrong, we can sometimes still correct that. In this case, as I said, we will just take the diamond tool away, and we will start at this point again. We'll make a drill here, and then this movement of the diamond tool would make us change the angle. We'll see it on the next slide. Okay, we've talked about these two. This is, you see, we took the diamond further back, and now it's actually showing us the correct angle, and we have the distance that we wanted. You can see it here. We have the distance that we wanted, and we have the correct angle. Now, I'm not saying this is easy. It's not. And we need to make sure that we are measuring at the right position and so on. But it is a tool, a measuring tool, that once we practice could help us understand what to do. It is not obvious like the orbital angle checking, because this can be done outside of the face just looking. It is more difficult doing it that way, but it is a tool that once you practice actually gives you results. Okay, so now that we understand what to do, let's see what happens when we actually do that. So we take the diamond and we come from this starting position down to this position. We're actually in this position. When we came down here, we removed this amount of bone. That's the amount of bone removed. And as I said before, this is the actual implant that we want to be placing. And this is the measurement that we measured and we checked, and we know that we are okay. But what happened if we went further down? I've described that. When we went further down, this distance is shorter. And if we understand that, we can still correct it. And if we did not go down all the way, the distance is much higher, and then we know that we have to go further down or move the tip of the implant further in. Okay, the correction of this angle can be done in two ways. It's either going with the tool further down or moving the tip of the tool to a different location, upper or lower. It's something that you have to analyze when you do that. And that's how it looks actually in real life. It's if we didn't go to the right position, we are actually pointing to the temporal fossa, and this is the correct what we've done, what we wanted to do. And if we went not the correct way, we have much less bone here than we have here. Okay, so this is what we wanted to do, and we have a tool to do that. And that's how it looks. We take the diamond, we make the groove. That's how it looks. We see the Schneiderian membrane in this case. We see the bone on the crest here, and this is a bone guide right now, where we lean the drill on this groove, and we have the entering point for the tip, and we can just start drilling. And we still have the mark, the pencil mark, so we can look at it, and we put our finger at the expected position where the drill is going to be out, and we drill. Another picture of another case. Okay, we can, in some cases, we can push inside the Schneiderian membrane in cases where we perforate the bone. And now we take the drill. As I said, we lean the drill on the bone, and we drill until with our finger we feel that we perforated the zygoma bone. Why do we want to perforate the zygoma bone? Because we want to have a bicortical anchor for the implant, and this area of the bone is cortical bone. The zygoma bone itself could be type 4, but it is cortical bone at this point. So we want to perforate this bone. Another reason we want to perforate the bone is we want to make sure that we are using the longest implant possible for this case. Because if we did not perforate and for some reason we stopped here, we would be using a shorter implant. And in this case, shorter implant is not what we want. We want to have the longest implant to come and be anchored on the cortical bone here. Okay, so this is a very important point. Okay, this is when we drill this drill number 1, that's what we have with drill number 1. Okay, and that's how it looks. Now, once we have drilled, we want to make the correlation between what we drilled to actually what implant length we want to use. For that, we're using the depth probe, where we want to put the depth probe in such a way that will define us this point where the implant would be. We don't want the implant go further out. We don't need the implant to go further out. What we do need is the apex of the implant to be anchored on the cortical bone here. Okay, so that's where we want to be. So if we push it further out, we're actually going to measure and have a longer implant. So we want to push it. We want to actually put the finger here, push it and fill it with our finger, lift it up and pull it back until it stucks, until this depth probe is stuck like that on the bone, and we don't feel it in the finger anymore. And now we are in the position to actually read the lines of the depth probe. Okay, like that. That's where we want to be. Not like that, like that. But it's easy. It's better to start this way to feel the tip of the tool on the finger and then pull it back, stop here. Okay, so let's have the correlation between the depth probe and the implant itself. And this will be the correlation that we're looking for. What we actually want to know is where the center point of the multi-unit is going to be. When we look at the crest and we want to start measuring, we have to imagine where do we want the multi-unit to be. Okay, this multi-unit is going to be positioned this way. We want to know where it is. And then we measure the distance from here to the position on the crest that we think the multi-unit would be. Now, because the multi-unit is about between 2.5 to 3 millimeters, depending on the multi-unit, away from the implant platform, that means that we have to reduce this distance. Okay, so we are going to reduce 2.5 millimeters from the measurement that we have. Okay, so for this implant, actually, we're going to count the lines 1, 2, 3, 4, 5 lines, or 5.5 or whatever. Okay, in this case, it's 5. And 5 millimeters tell us that the length is 55 millimeters, and we see it here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Or if we measure, or if we count from this way, 1, 2, 1, 2. We always come to the same distance. So in this case, in this case, what we want to have is a 55 millimeter implant. That when we place the 55 millimeter implant and we put our finger here and we don't perforate the bone, because we don't want to perforate the bone. We just want to be at the cortical area here. The platform is going to be in a position that when we put a multi-unit, it's exactly where we want the multi-unit to be. Okay, this is important to understand of how to measure and decide implant length. And that's actually how it looks like. So we're counting the lines and deciding the implant length. Now, placing the implant, when you place the implant, basically the implant goes all the way here. This is drilled already, the 4.2 drill. Okay, so the implant goes in, and now starts, the thread are now going to be going down from 2.5, 3 millimeters, going inside. Okay, and this is where it went. You see, this is the distance leaving us for the multi-unit, and the edge of the implant, the apex of the implant, is exactly at the point where we want to have it. And you see, this is the amount of bone this implant has condensed. Okay, this is the amount of bone it condensed. That's how it looks. So we have the orbiter here. This is the angle, and we actually put the implant in. And sometimes it is difficult to find the line after we have drilled it, because sometimes we fall into the sinus. So one of the ways to do that is to take the depth probe to find exactly the depth probe where we are, put the implant parallel to the depth probe, and then just follow this line. Sometimes it's easier way to do that. Once we place the implant on the crest, we have to remove the bone on the crest, because it might affect the fitness of the multi-units. Okay, so we close the implant with the cover screw, and we just remove this bone without injuring the implant platform. And then we take the screw out, and we can put the multi-unit in. And that's how it looks. Okay, we see the multi-unit very nicely positioned, and the multi-unit is in place. You see, this is the distance we took less, as I said before, the 2.5 millimeters less over here. And that's how it looks in life. Okay, let's talk about the parallel view for posterior implant positioning. Just a second. We have, when we place a posterior implant, in this case, the posterior implant is crossing the anterior implant. You see the apexes are crossing one above the posterior implant is above the anterior implant. Okay, that's how it looks. The posterior is above the implant. I will show now, to understand, I will show now how to find the entering point of the posterior implant, because this is not enough to check the height. We also have to check that we are not colliding with the anterior implant. This is also a question that is, I don't know if there is everyone is we have two views about that. What should be done first, the anterior implant or the posterior implant? And some would say the anterior, and some would say the posterior. I've heard some explanation why to do the posterior first, because sometimes it is important to be able to put it as distal as possible. That's why I'm putting it first. But for my opinion, and it's only an engineering opinion, not about that, take it as that. My opinion says, first of all, we need to put the anterior implant, because we need to position the anterior implant as close as possible to the orbit, with nothing interfering in our decision where to put it. This is the most important thing. And then we take the posterior implant and we position it the best we can based on the anterior implant. The other way around, if we start with the posterior implant, not checking that, we might be wasting bone that later on will be very difficult for us to position correctly an anterior implant, or maybe not at all. Okay, so our view is like that. We don't see. Okay, but even if we raise the flap, this is about what we see. Don't forget that. Now it's a very nice model, but actually in life it looks like that. And we want to be able, even though it looks like that, to find the correct entering point. Okay, so this is the view we're having. Okay, in this view, we see the implant one on top of the other, and basically this is the implant. But are they touching right now? How could we know if these implants are actually touching one another? From this view, we cannot know. We don't know. But there is a view that we will know. If we look from, okay, let's look at this short video. If we look from another angle, now we can see that they are not colliding. We actually have a distance between them. Okay, so if we have a distance, if we look, when we put our face in such a way that we have the implants parallel to one another, and we have a distance between the implants, this distance here, okay, if we have a distance here, that means that they're not colliding. That means that this is the distance that they have, okay? So we actually move our face to this angle until we see the implants parallel, and we measure with our eyes if this distance here, if there's a distance here or not, okay? Look, if the implant is going down, look that this point has changed. Look what happens if this one is going up and down. You see, this is what's happening. And for each one, we have a different distance when we put our face at the right angle to have the implants parallel, okay? In this case, we see that the distance is very, very short, and it actually is very close to one another, okay? You see, when it's touching like that, we will see that basically when we put the implants parallel, we have no distance between them. That means that we are not going to be colliding. And this we can analyze before we make the decision for the entering point of the posterior implant. We have to guess a point and to start going down with the diamond following this angle, okay? And going and moving our face to see the parallel view and to see that we have a distance here. If we have a distance here, the implants are not going to collide. One other thing we need to check is the distance we have from the top of the bone, because we sometimes want to lift it up and down, but we're actually going to be out of this bone. Okay, so we have to check two things. We have to check the distance from the bone with a measuring tool that we have done before, like checking the sinus angle. We have to check this distance. We'll see it on the next slide. And we have to check that we are parallel, because only when we are parallel, the distance is reflecting correctly. Any other angles that we see which is not parallel, we don't see the true distance here. That's how it looks actually. So when we have the implants parallel and there is a distance here, this is the distance, the actual distance that we have here. Okay? If, for instance, if we move our face and we see that we're having a small distance here, that means we are having a small distance here, okay? If we have no distance at all, we are colliding. The implant is going to be colliding, okay? So let's see how we do it with the diamond burr. First of all, we have already the anterior implant positioned, and we want, as I said, we want to have it positioned as close as we can to the orbit to give us the most amount of bone here for this playground we're at. And we guess a point here. We just guess a point. We make a hole. We make a drill, a small drill, and we put the tip of the diamond in this drill. And we start going down. Okay. When we go down, we see the distance between the diamond tool and the drill. And we look from the other dimension, from other direction from here, we see we have no distance. I'm showing this case where we have no distance. Of course, we could have distance on the first trial, but if we have this kind of way that we have no distance, and we've already moved the diamond down to this position, that means that we have to lift this point up. Okay, because now the implants are colliding. In order for the apex not to collide, we need to raise this point up. Okay, and we can see that. Okay, we see that basically we are going to be colliding with the implant because there is no distance here. Okay, and this is the view that we put our measuring tool. The measuring tool is actually checking the distance of the bone here. Here, this is the bone here. Okay, this is the view that we're putting the tool, the measuring tool, not here. Here. Okay, we want to make sure that when we start the tunnel here, we are going to go above this point here. That's the view. Okay, so we put it here, we check the height, and we do this grooving. Okay, so as we're doing that, we took the diamond, we went down, and we see no, let me just go back here. Because we see that this point is too low and we need to raise it, we raise the point, we check another point, we do the same, and now we check in parallel. We see in the next slide, we check in parallel that we are okay, and we check the height. We have enough height here that we are okay. In this case, we want to have the maximum height here and not colliding with the implant with the parallel view, okay? That's the way. This is what we see. We take the diamond, we check the diamond, we see that when we are parallel in this position, we have the distance here and we have enough height of bone here. That means that if we drill now, we are going to be positioned correctly and not colliding with the implant, and we have enough bone above to drill. So actually we found the entering point for the posterior implant, like that. So let me just summarize the method for the posterior implant, because this is done simultaneously. We have to move our face from this view, the one we saw here, from this view to the parallel view. We need to move our face between these two views and make a decision. We would start, then we will move it up and down until we are certain that we have the distance here, and then we are set. Okay, this is the trick. So if to summarize here, we now know how to enter the anterior implant on the right angle of the orbital angle. We know where to enter the point because we measured the height. We know how to enter a posterior implant because we found the entering point, and we know that we're not going to be colliding because we have the parallel view. This is the very important to take home with. Okay, let's talk a little bit about pterygoid implants. I'm not going to describe the bone types or how or anything which is clinical. I just want to show the ways of the angles that are involved when we're placing pterygoid implants. And further on, we'll go through live models through the software and we'll just look at that. So just on a brief, we have, Norris has two kinds of pterygoid implants. One implant is the TerryFit, which is a between 18 to 25 millimeter length implant. It has two tapers. The apex diameter is 2.5 millimeters. You see, it has two angles going up to 4.2. We have the color of the implant for a length of 5 millimeter. It's machined, and the reason for that is that pterygoid implants are placed on an angle, and on the position that they're positioned on the tuberosity. If they would have, usually there is a bone resorption there, and in order for us to be able to clean, and taking into account that this area of tuberosity bone, there's not going to be any integration over there. The integration is actually on the zygomatic bone, and that's why we have these threads with surface finish. This is very important to have a machined collar. So we have this type of implant for pterygoids, and just to understand the drilling protocol for the pterygoid implant. I did not prepare it here, but actually the drill that we're using is, the last drill would be 2.8 millimeters. And when we take this implant to a 2.8 millimeters, it just goes in and we have very, very strong torque. We also have another implant, which is called TerryCore. It's an extension for the cortical implant. You see, it has a very similar geometry like the cortical implant, and also a machined neck working the same way as this implant. So we have two options for pterygoid implants. Okay, so what we want to do in pterygoid implants is actually to position the implants where they are anchored on the medial plate. We are not allowed to go towards the external plate, because over here we have the plexus, and we don't want to be there. So our aim is to be towards the medial plate or towards the pterygoid fossa. Okay, this is the actually angles, and these angles are something like 30 degrees, like we see here, 30 degrees. Okay, if this is the center, 30 degrees. The entering point would be somewhere from the tuberosity to the entering point would be somewhere between 10 to 15 millimeters, depending on the case. Now, and the implant is actually leaning something like 30 degrees, 30, 45 degrees. It depends, but this is the rule of thumb. That's where we are starting. That's where we're starting to look. Okay, so if one way of giving us a clue is actually the humulus, because with the finger we can allocate the humulus, and actually the plane that we want to work through crosses from the entering point through the humulus toward the medial plate. This is the plane where the implant is going to be positioned. Okay, so if we look from the side, okay, we see that we are actually now outside of the sinus. We're distally to the sinus, going toward the medial plate here to this position, and we see the medial plate here. Okay, so we're going from here, from the crest. This is the crest. This is we're going toward the medial plate. The only bone which is actually going to help us to anchor the implant is this cortical bone of the medial plate here. Okay. Now, one of the ways to find this angle when we do that freehand is actually we don't start drilling and perforating the bone in wishing to have the right angles. The way to do that is to take an osteotome. We have an osteotome for that. We actually position the osteotome at the expected entering position with the 30 degrees to this way towards the humulus and medial plate, and 30 degrees from the occlusion plane, and we start pushing the osteotome in this direction. We push it in this direction. Let me see, maybe we see it better on the different, yeah, we start pushing the osteotome this way. Now, because the tuberosity bone is very, very soft, we just fall inside until we hit the cortical bone of the pterygoid, or not, because we might be in the sinus. So we sometimes fall. We'll see it in some different models. We can fall to the sinus and then we hit the bone. Okay, but as long as we're doing that with an osteotome, we are not damaging anything. We're not damaged the bone yet, and we can still correct and enter to a different position. But we do that until we think that we're in the right position. We push, we hit the osteotome to make some kind of an entering point to the cortical bone. Then we can take the drill, a 2.3 drill from the set, and we have the angles, and we can drill the expected correct angle. It's only expected. It's very difficult to know that for sure in real life. Okay, let's in this case, we are distal to the sinus. So when we put the osteotome this way, it will fall all the way here, and here we'll probably start feeling the cortical bone in this point, and then we will switch to a drill. Okay, let's look at a different case. Again, we are having the same angles as I explained, okay, going towards the medial plane. In this case, we are almost at the sinus. Okay, this is the tuberosity here. Okay, this is here the tuberosity here. It's this point here. Okay, it's this point here. Sorry, this is the tuberosity. We push the osteotome to, and in this case, we might feel some strong bone, but in this case, we can use the drill. If we feel strong bone here, we can use a drill. We see that our angle is taking us towards the medial plate in this section, and this is actually what's going to be holding our forces. We always have to remember that the osteotome, the pterygoid implant, is the forces come this way. That means that basically this implant wants to rotate around this point. This could be a fulcrum for the implant. We go this way. So if you don't have enough bone here, this implant might be moved. So that's why a pterygoid cannot stand for itself. It can only be connected to a denture, okay, to a fixed denture. Otherwise, it will not hold. Okay, another angle we see same. You see, we start here something like 10-15 millimeter towards the humulus, taking us towards the medial plate. Okay, but in this case, we fall to the sinus. So when we take the osteotome, we will fall inside the sinus. We will feel this entering point, make a mark with the osteotome, and then we can drill. And we keep these angles because we can fall. In this case, you can fall either to the pterygoid fossa or to the other side. Okay, so if we start drilling and we feel that we are actually not drilling and we have no resistance, we have to check ourselves. Another case, again, going toward the medial plate through the sinus. Okay, so this is actually the angles for the pterygoids, and later on when I go to live cases, I would just show it on 3D software. Okay, another case. This case goes to the temporal fossa, to the pterygoid fossa. Here, you see, it's going to the pterygoid fossa. Probably there was not enough bone on the medial plate. Look at this. This is the tuberosity here. This bone, it's nothing. This is actually what's holding the implant. Okay, you see. Okay, so now we will go through some digital planning for zygomatic implants on software. And let me just do that. I've shared a screen now where we have the software that we can plan. We can plan any implant, but it's very it's very easy to plan the Zygomatic implant. It's called EasyPlan, and it's our software. Let's look how the angles are actually. Okay, if I look at the anterior implant, okay, what we see it here. If I put a view here, yeah, I have a view. I can look at the view here, and when I rotate here, I can see the section rotated. This what we see here. Let me just what we have on this plane is what we see here. Okay, so I'm rotating. What we see here, we see this is the orbita, and this is the ridge. Okay, this point is here. We're looking right now at this angle here. You see here. This is what we're looking at. This is the angle. We see what we see here. This is the amount of bone supporting. This is not a case for anterior zygomas. It's just a very nice case to explain the angles. Okay, so in this case we could put a regular implant here and just put the zygoma in the posterior, but it's very easy to explain. So forgive me about that. Later on, we'll see other cases which are more difficult to do. Okay, so what we see, this is the distance to the orbit. Okay, if I move the implant towards the orbit, let's say I'm very close to the orbit now. Okay, okay. You see, I'm very close to the orbit now here. Let's see how we are from this angle. If we were to be very close to the orbit and we look from here, and we look from here. Okay, from here, you see this line actually takes us very close to the orbit. So we might think, that's what I explained before, we might think that we're not in the orbit here, but actually we are. Okay, so we need to make sure that we're on the right distance here. You see this, how close we are? And this can be seen if I rotate, now I rotate it, okay? I rotate the, okay? I could take it out a little bit, like that. Okay. See, this is how we are, but we're still very close to the orbit. So we would not plan it that way. When we plan it digitally, we just take the implant. Let's say this is fair enough. Okay, and we are now far from the orbit. Okay, we could also move. We can also move the. Let's say we want to put the implant on a different position. These implants are already placed. I've placed them before, but in order to save us time. But let's just play around a little bit. Okay, let's say I wanted to change the implant to a different location. let's say I wanted to make it stick it distally. Okay, let's say this is the angle I would like to have. Okay. Now again, I will put it here. Okay, put it here. Check where the distance. The way I do, I just make a full rotation, and to see the minimum point. At the minimum point, I will just move it away, move it a little bit. I'll move it to the distance that I want it to be. The distance like that. Okay. Okay. And okay, so let's say this is what we want to do. Now, one of the things we need to understand that when we measure, then we decide where to put, where to see if we have support on the ridge or not. We need to make sure that we're looking at the right angle, because the forces work on this direction, perpendicular to the occlusion plane. Okay, this is somewhat perpendicular to the occlusion plane. Okay, depends. But we want to check this way. If I for instance put the view like that, this is not the way the forces work in this case. Okay, the forces work on this plane like that. Okay, and let's see, we have a lot of bone. We'll see later on where we have no support of cortical of alveolar reed at all, and we'll see how important it is. Okay, so this is how we check. Okay, let's let's see how we position the posterior implant. Okay, so again, I put the posterior implant, and I want to make sure. Let's say this is the position I want to have it. Let's say maybe more. I will have it even more distally, and from the point that we're looking now, we want to have the implant. Just a minute. We want to have this angle of the implant. I can do it here better. I will do it here better. Let me just put this on. I want to have the implant, let's say, I want to have the implant this way. That's where I want to have the implant, okay? I'll shorten the implant. And let's see what I see from the parallel view. Let's see if I can put the implant without having any collision with the anterior implant just by using the I need to move this around. How do I move this around? Okay. Okay. If I, for instance, lift it up, okay, and I look from here, I look from this angle, okay, they're not colliding. We see that, right? Because we have on the parallel view like that, we see we have a distance. If I take this off right now, if I mark this off, just a second. If I hide the bone, you see, the implants are not colliding. When we have them parallel, we see view. If we take it down, and from here, it's like that. They're crossing, but they're not touching. Okay? When will they touch? You see, now they're not touching. If I take it down further, like this, they're still not touching, and now they are much closer to one another. And if I take it furthermore, now they're touching. I can see it because there's no distance here, and you see now they're touching one another. Okay, so we need to have this done in real life. Okay, let me put that back. Okay. The minute I rose it up, I have this distance. Now, if I want to have if suppose I don't have enough bone here and I want to be as slow as possible, enabling a lot of bone here, then I would have this distance small. But if I have a lot of bone and I don't want to have any problems, I can lift it up more, like that, for instance, move my face to this position, and you see I know I have a different distance here, okay? So this is the way we use. Now, what I've shown here is just the understanding the parallel. Of course, we do that, as I explained before, we do that with a diamond. We guess a point, we start going with a diamond, first of all, on this line. We put a point here, we go on this, we mark this line, we go this line, and we start removing material from bone from the crest. And all the time, we have to look and to see that we are when we are parallel, we still have this distance here. I'm repeating myself because it is so important, so important. Okay, let's look at the pterygoid we have here. You see this pterygoid here is actually now positioned towards the medial plate. You know, let's take it out. Let's take the implant out. We took it out, okay? And I'll just move it around, so we'll see what to do, okay? So this implant right now is going, first of all, I'm going to position the implant somewhere about, somewhere about 10 millimeters from the tuberosity, something like that, okay? The implant is actually going to be on the buccal side of the crest, okay? It's going to be on the buccal side of the crest. You see now it's pointing, this is the medial plate here, okay? Let's see the view that we have. Oh, just a second, I lost you. Yeah. Okay, this is the medial plate here. Let me just have my annotation. Okay. This is the medial plate, so we want to be aiming towards the medial plate, and we want to be on the buccal side of the crest this way, okay, like that. And when I rotate myself, I want to see that actually now you see, I am here right now in the medial plate. I'm going towards the medial plate. I could take the implant further distal this way. This is cortical bone here. And to this position. So when we do that planning for guided surgery, we can be very accurate, but when we do it freehand, it's a different story. Okay, so this could be a nice position for a pterygoid. Sometimes we will change the position so that the multi-unit position will be correct for the restoration, but this would be the way to do it. Let's look at the pterygoid on the other side. Maybe it's different. Okay, we're also positioned towards the medial plate here, and far away from the sinus, okay? Far away from the sinus. Okay, let's take some other cases and see what we have there. But for that, I'm going to have to switch to another software, so it might take a second. And yeah, okay. So now we're going to look at the case of a symmetropic maxilla. It's a hybrid implant, taking into account an anterior zygomatic implant in the future. We talked about that. The zygomatic bone is medium and there's no support on the ridge. Okay, I'll share the screen right now. This is the case. This case was planned towards restoration. So we know the teeth position. We know how to position them using the gutta-percha points. So this is what we have. I will remove the restoration, or even before that. Okay, let's look at the implant position with the restoration. So we see the implant position. Okay, we see it here. This is a very, very thin atrophic maxilla. Okay, and the implant is anchored in the zygomatic bone, and very short location for the restoration here. Okay, because we did not want to perforate toward the palate here. In this case, we did not perforate, and it's better for the future. Okay, let's look the other side. Typical, but very, very similar. You see, very similar. A little more on the crest. Okay, you can see that. Okay, so this is a typical hybrid case. Okay, we see that we have implants anteriorly, like that. Okay. We could decide to position a zygomatic implant here instead. This implant, we don't know how long it's going to live. This is an implant mesial to the incisive canal. Okay. So it was decided in this case to use those implants right now and leaving space for future zygomatic implants. Okay, so if we do that by actually, let's put a zygomatic implant here. I'll just put an implant. Okay, so I have an implant here, but I'm trying to check right now if this implant, if we have enough, if we plant a posterior implant in such a way that it would leave us the ability to position an implant in the future, okay? This is what we talked about before. And we see we can. See, we have the implant here. We can take it further towards the orbita, like that. Like that. It's touching. What we see, it's colliding the sleeves, okay? But we see that there is a position for us to position an implant in the future. Let's check around ourselves here and see if we are okay. Okay, we are okay. And this is a hybrid with the positioning of the posterior implant enable us for a future zygomatic implant, okay? So this is one case. Let's take another case. Now we're going to be looking at case 370 with a knife edge and quad crossing. Okay, let's do that. This would be 370. We have another case. In this case, we have a knife edge. Okay, we see the knife edge. Let me just take this away. We see the knife edge. Okay, and in this case, again, we can either put regular implants. This implant is positioned in the incisive canal. Okay, this would be another implant. Now, this one is another implant that can be positioned on a very, very small bone in the crest here. In this case, it's not recommended in this case doing this solution. I would go to the zygomatic implant. I just wanted to show that there is an ability to do that. Let's look on the right side. You see, this is a more severe, this is a more reasonable implant position. Okay, so basically we could have 2 implants on the left and 1 implant posterior on the right. And in the future, having this implant position. So let's just look at the zygomatic implants. If we're here, so we see, well, this is what we see now. Let me just put this on. This is the angle where we see the orbit. Here we see the orbit. You see this is the distance, the closest distance here to the orbital rim of the implant, okay? This is the distance, like that. And this is the distance from the posterior implant to the anterior implant, okay? This is the distance we have here. We have here. I can't do that. Here we go. Here we go, okay? That. There we go. Okay, we can see on this, this is the angle that we're checking to see where the forces are working. Okay, this basically is the angle where we have the multi-unit perpendicular to the occlusion plane. Okay, and we see again we have an implant on the zygoma bone. We are not perforating the sinus, the maxillary sinus wall. We have small crest, but we cannot count on this. It's nothing actually. And all of the moment here is being held by the zygoma bone. Okay, if we look at the anterior implant, I want to show something very important. The anterior implant, we also need to check on this, as I said before, on this angle. Okay, and we see that we have a lot of bone here in this case. Okay, let's look at the other side. We saw before that here we could place an implant, but we can just see this. You can see we're making a section through the crest right now, like that. This is the angle that we're looking at. A lot of bone here. Okay. Let's look at the posterior implant. This posterior implant has a lot of bone to lean on. It's not like on the left side where we had no bone. The left side, to remind you, we had no bone. The right side, we have a lot of bone. Let's look at the pterygoids that we have here. You see what I said before is actually we have the pterygoid leaning on the crest. This here is machined. This here is machined. We don't need this to be, with surface finish. We need this to be machined, okay, because it's outside of the bone because of the angle that it is. This is the reason it's very important to leave a pterygoid implant with machined surface here, okay? Okay, let's look at the pterygoid themselves. The implant is going towards the medial plate. You can see that. It's going towards the medial plate here. Let's look at the other direction. It is perforating the sinus, okay? Perforating the sinus. Okay, this here, this is the tuberosity here. This is the point of the tuberosity here, okay? This point here is this point here. This is cortical bone. So this is a tuberosity. If we take, as I said before, if we take the osteotome, we'll just fall inside, and this would be the direction here. And if you look from here, again, you'll see that the angle is going through the humulus towards the medial plate. Okay, so this is a very important point to feel with the finger. Okay, let's look at the other side, again, going towards the medial plate, like that. And on the other side, going to the medial plate here. You could even take a longer implant. Let's see if we can take a longer implant and take it, let's say, like that. You see, it's here. This is cortical bone. Okay, let's take another case. Just come back to the presentation. Okay, we take another case. In this case, we're talking about a semi-atrophic maxilla. It's also a little bit of cortical, of knife edge. And it's anterior supported, okay? Posterior supported, no, posterior non-supported. Let's look at that. Take me a second to put it on. This was not planned towards restoration. Let's look at the anterior implant. Just put on my mouse. Okay. Let's look at the anterior implant. I'm looking at it right now. Okay. Let's put our view. Okay. We're checking now how far we are from the orbit. This is the distance from the orbit we are. You see, we are here. Checking this distance here right now. So this would be the minimum distance to the orbital rim here. Okay. We are leaning on the crest. I will be saying that after I'm putting this section on the right angle, okay, on the angle of the multi-unit. And now we can see that we are actually supporting by the crest, anchoring in the zygoma. It's a short zygoma length, but because we have support from the crest, we can allow ourselves to be that way. If we had such a short amount of threads in the crest with no support here, it would be, we had to consider if it's okay. Usually, if we have that, the goma doesn't work for itself. It's part of a construction, and we have to look at it as a construction. So when we have all the multi-units combined together on a fixed bridge, then basically we have a construction, and this position doesn't work as a moment. It works differently, and it works. Okay, so we have to take this into account as well. Okay, so this is the anterior implant. Let's look at the posterior implant. You see, we are far away from, we are not colliding with the implant, even though we are almost crossing, we are not colliding with the implant. Okay, we do have, however, on this angle, okay, the angle of the multi-unit, we have very small support from the ridge. Okay, let's look at the other side. What we have here, very similar. We'll be checking this way. We have support from the ridge. We have a long zygoma bone. And let's see how far we are from the orbit. This is the distance we have from the orbital rim here, over here. This case was done guided, so it's okay to do that. Let's look at the posterior implant. Okay, we are. Let's check ourselves on the right angle. We see here that we have no bone on the crest. Okay, no bone here. Let's look at the pterygoids. Okay, so let's look at these pterygoids. Okay, this pterygoid is, I will rotate it. See, it's going, when I look at it from this direction, here, this way, the direction of, as I said before, the humulus, the plane that we're looking at, okay? If we're looking at this plane over here, we see that, we're perforating the sinus and going to the bone. What can happen when you take a drill to this point? When you come with a drill to this point, the drill can slip. If we don't have if we don't stop at this point and make like an entry point, when we put the drill, it might slip and we might find ourselves falling into the sinus. So if we use an osteotome and mark this point, that it will prevent the drill from slipping, and we will be able to manage that. Otherwise, we might find ourselves falling inside. We can also, if we don't take care, we might lose the implant. In this case, it can just fall to the sinus. Okay, so this is the angle taking us towards the medial plate. Let's see how we are on the side. On the side, we are like that. Okay, so if we look on this angle, we are here. The medial plate is very small, so actually we are almost at the pterygoid fossa here. Okay, let's look at the other implant. Okay, aiming towards the medial plate and perpendicular, we are in the medial plate. Okay, here we are. Okay, now we will go to the final case. It's a very atrophic case. We'll look at that one. I will switch to the case. It'll take a minute. This is the last case I will be showing today. This is a very atrophic maxilla. We see here no support at all. Okay, let's see how we deal with such a maxilla. Okay, let's look at the anterior implant. Anterior implant, and we're going to check the anterior implant, as I explained before, where we are checking this on this view, like that. Okay, and when you do that, you do the same. You have to understand the views when you do it freehand. You have to understand the views. Okay, we see this is the orbit. Okay, we see the orbit here. This is our distance to the orbit here. By the way, we talked before, look how far we are here. Look how far we are here. Okay, so if you measure, look how far and how actually close we are to the orbit. okay? We have to, this doesn't always tell us if we are right. Sometimes the orbits are very low, they go down. We need to make sure that we know where we are, okay? Actually, we could take this implant. Let's see if we can do that. Let's take this implant higher up. Let's see what's happening. Suppose we did it this way, okay? We're still, okay, here we are, we're still close to the orbit. Let's take it out a little bit. Suppose this way, and then take another view this way and lift it up. I'm trying to see if we can position it on a different way. If we position it this way, you see that we have the implant not, it doesn't lean on the maxilla, okay? That's why you won't have the implant further in like that. Okay, we don't have the implant, let's say like that. Let's see where we are in terms of the orbit. We're very close. Okay, that means we cannot do what we want. We will need to take this down this way and find a better position. But this is a very tricky case. Doing that without proper checking on a 3D software might lead us to make some wrong conclusions, because if we did not know that and we would just, let's say, put it this way, knowing that this looks to us like a reasonable distance, we would be actually in the orbit. Okay, so don't always check it before we approach a Zygomatic case. It's very important to check it on 3D software. Okay, so this is the position. Okay, I will take it back a little bit, so I would still be far from the orbit. Okay, now I'm far from the orbit and I'm in a reasonable position. Okay, there is no crest support at all, but I need to check it on this angle. I did not say it correctly. I would check it from this position. There is no crest at all, yeah. Okay, but we do have a very strong zygomatic bone that will take this moment here. It's very strong, it's very long. This will hold. I'm not afraid of this not supported here. Okay, let's look at the posterior implant. Let's try to do it again without looking here. Let's try to position using the parallel view. Okay, well, you see, when I'm parallel right now, I have this distance, so I know I'm not going to be colliding. However, I will not be colliding because I'm actually not crossing. So I don't even have to check that. I can take this implant even lower. And even though that now when I put my view and I'm parallel and I see no distance, I'm not colliding because actually I'm not crossing. Okay. The rule of parallel is only when we are crossing. You want to check the crossing, okay? Because if we come and see that we are here, but we are not crossing, then we have no problem. Okay. So let's just take it up a little bit. And now we see that we are in the temporal fossa, so I'll just move it back, move it. You see, this is here. This is falling. This is the temporal fossa. This is this area here. Okay, so I will move it. Let me do it again. I will move it this way, like that. Okay. Now maybe I am crossing, and I am. You see, now I am crossing, so I have to check from this position. Let me just see. I have to check from this position that I am not touching. I'm very close. We can see here that we are very close. Okay. So I would lift the implant a little bit this way, change my view. Now I'm not colliding. And if I check here, you will see that I'm not colliding. Very close, because we're very close, but we're not colliding. I can lift it up a little more. I can either lift it up or I can take it down here. same thing. Okay, taking down, same thing. I increase the distance here. Now I can lift it up a little bit, like that. And when I look from here, now I have now I have more space, which is here. Okay, so this is a very, very important tool, the parallel view. Okay, let's look at the pterygoids. So we don't have any medial plate here, and we are aiming towards the the pterygoid fossa, which is here, and we are actually going this way. We don't have a lot of bone here. If we lift the implant up this way, okay, like having this angle very low, it's not good for us. We need to have this angle. What we could do is take the implant more distally, then we have longer bone to be anchored in. Let's look at the other side. Yeah, maybe this way. Okay, so this is not a very good pterygoid, but this will hold, and it's good. It's a good pterygoid. It will hold. Okay. Let's look at the other one. See, in this case, there was already an implant here that failed. And that's why this implant was put mesial to this implant. The current implant was removed and another pterygoid was placed towards, it had to be more mesial, so it's not exactly the positioning of a pterygoid, but it's still working. It's going towards the fossa here, towards the medial plate here, and it's going to hold. You see, it's going to hold here. Okay, I've come to the end of the session. I hope you have enjoyed yourself and you learned a lot. And I will be seeing you, I hope, in session 2, where we will be speaking of, there will be a short I'll return shortly on some rules here, but we will be seeing how this procedure is done guided with the Zygoma concept. So I'll hope to see you then. And thank you very much for watching. Bye-bye.